During conventional assembly, both single-sided, double-sided plated through, or multi-layer boards can be assembled. With a lead-free process, it is important to check the finish on the PCB does not contain any tin lead. In some cases, it may be necessary to mask some of the through holes when certain components cannot be wave soldered or cleaned. In this case, masking is used to prevent solder filling the plated through holes. If the assembly is being cleaned after soldering, a dissolvable mask may be considered. Some lead-free finishes like OSP, silver and tin can be affected by the masks and washing, and should be tested for compatibility before use. If the printed circuit board contains surface mount devices on the bottom side, adhesive will be dispensed or screen printed onto the printed circuit board. Components will then be placed into the adhesive before curing. This will commonly be conducted at 120 to 130 degrees Celsius. The board would then be turned upside down for conventional assembly. Normally, automatic insertion may be employed for axial, radial or dual inline devices. The components are inserted, then the leads are cut to length and clinched to secure the component into the board. Care needs to be taken to check the components for lead to avoid solder bath contamination. Semi-automatic equipment may also provide a cutting and clinching operation. Next, any odd form shaped parts or components which cannot be automatically assembled are inserted into the board by hand. If all components are assembled manually, then either all component leads must be preformed, the correct lead purchased, or all cut after assembly using specialist equipment. The next stage is the soldering process. In traditional wave soldering, the flux is applied to the underside of the board by passing it over a foam fluxer. The foam is produced by forcing compressed air through a porous stone submerged in the liquid. This produces a foam head which is supported by a nozzle. A low pressure air knife located just after the foam fluxer removes excess solvent from the underside of the board. This prevents it dropping onto the preheater as it passes through the machine. Traditionally, alcohol fluxers are used in the industry, but with moves to use a greater number of water-based formulations. This is for environmental reasons, but the materials are less volatile in high temperature preheat and lead-free wave soldering. The preferred method of fluxing for low solids materials and nitrogen soldering is spray fluxing. A thin layer of flux is sprayed onto the underside of the board. Any overspray is either extracted or caught in an absorbent filter over the spray head. As the board passes through the fluxer, sensors monitor the board length and conveyor width, preventing any excess overspray. The flux is stored in a sealed container. It doesn't degrade, evaporate or require monitoring apart from the level. Traditionally, alcohol fluxes are used, but there is a move to water-based fluxes for environmental reasons. With low solids flux, the aim is to apply the very minimum deposit. To assist the spray to enter small plated through holes, an air knife can be used to aid penetration. Alternative spray fluxing systems include drum fluxing, where a mesh drum rotates in a bath of flux. As a board passes over the fluxer, a slot opens, and an air knife atomizes the flux from the mesh, spraying it onto the base of the board. A similar operation takes place with a flick fluxer. In this case, a brush rotates in a bath of flux, and when a board passes across the unit, a slot opens and a plate slides into contact with the brush, deflecting the bristles and flicking the flux onto the base of the board. After fluxing, the board assembly is preheated to activate the flux, dry out the solvent carrier, and reduce the thermal shock to board and components. The temperature on the top side of the board should be 100 degrees C. Lead-free will require slightly higher temperatures of say 110 to 120 degrees Celsius depending on the board type. An alternative preheating system has been developed for water-based fluxes. This is based on convection. Hot air is blown onto the underside of the board as it passes through the machine. The board passes through the solder wave. A single wave is used for traditional conventional through-hole boards. Mixed technology circuits requires a double wave. Contact on the first wave is approximately 10 to 15 millimeters, 30 to 40 millimeters on the second wave. Lead-free solder baths will be maintained between 260 to 265 degrees Celsius. Higher solids fluxes or water-based materials seem to be more tolerant at higher temperatures and preheat settings. An additional feature on some wave soldering systems is a hot air knife, which is positioned at the back of the wave. As a board passes over the wave, and while the solder joints on the base of the board are still in a liquid state, a hot air or nitrogen stream can remove solder shorts between adjacent terminations. The use of nitrogen gas to displace oxygen at the point of soldering is used by suppliers rather than the old method of sealing the whole or part of the machine. Special ducting is used to maintain a low oxygen level at the wave when the board makes contact with it. Adjustments are made to the angle, air pressure and temperature to accommodate conventional and plated through hole and surface mount boards on the air knife. Rework and repair is conducted when necessary using specialist desoldering tools. It also requires suitably trained staff. Rework may be conducted earlier in the process if company quality standards are not achieved or components fail. In-circuit test may be applied at this stage to confirm the electrical integrity of the product. A bed of nails test fixture is used to contact the specially selected positions on the underside of the board. The same type of fixture may also be used for full functional test.